Welcome to another episode in the Web3Unity guide, guys. Now, today we'll be looking at something minor that plays a very big role in practically any blockchain transaction out there. We'll be looking at transaction checking. So when we, for instance, initiate a transaction, there's nothing really at the moment in any of these episodes that checks whether or not the transaction is a success. So we'll be digging into that today. Now, without wasting any time, we've got a script here. It's very simple, transaction check. We've got one string, the transfer transaction, which we'll be using here. So instead of a normal string or like a local variable, we're going to be setting a public variable to pass to a different function that we'll be creating that will check the response here, or the transaction hash, and then give back to us either a 0 for fail or 1 for success, and we'll execute based on that. Before we get too ahead of ourselves, we've got two functions here. We've got a transfer funds function, and we've got an approve function. Well, both of them are write functions, sorry. Both are write functions. This one here will actually send a transaction where we'll be sending 50 capsule to this address. It's a standard transfer method. If you think about, let me just zoom this in here. If you think about something like a normal ERC20 token, if you want to transfer, you have to transfer to someone and a value. So that's effectively what we'll be doing here. We're going to be sending two, so just a random address, and then the amount, so 50 capsules in this case, which is, just in case you're not aware yet, 50 plus the amount of decimals our token has, so 18. Now, there's nothing really preventing us from not having this amount of tokens, invoking this method, and then going to approve without any tokens being sent. So we need to make sure that when a user wants to be approved for the minting role, as an example, that they actually send us the tokens, and the tokens need to be successfully deposited into our wallet before we go to the next step. And that is where transaction checking comes into play. So let's see how we can convert this method and this method into a combined check method. So very first thing you'll need to do, if you actually go to the documentation, I worked on this yesterday when we were just overhauling the documentation. So you should be able to see, if we go into here, that this has been updated. So here you go. I've tried already submitting this in a format where it's fairly easy to understand, but all we're really after is this bit right here. Now the issue though with WebGL is that it takes a little bit of time before it actually takes or gets a transaction hash and passes it on to the transaction receipt here. Desktop builds are usually instantaneous, Android builds are instantaneous, but for today's demo we'll be using WebGL, which will take a little bit longer. So we'll need to invoke a method to check the transaction instead of having it, be in the same call like this. So if we go back to our script here, you'll see that we actually haven't specified a provider, which is fine. You might have a provider in here, wherever that might be, from like a contract manager and whatnot. But in this case, we won't, because we will need that provider in this check function. So if we then go and, let's start off, we'll create a new function here. It's going to be called something like, I don't know, check transaction. And the very first thing we need to do is specify a provider. Now, a provider, if you guys aren't aware just yet, is an RPC endpoint, something similar to this. You can get it for free from Chainstack and QuickNode. I'll try to leave a link again at the top there to show you how to get an RPC endpoint. And we'll just go, actually I made a mistake as well here. There you go. The provider will be a new JSON RPC provider. And in this case, because I already have this specified within my contract manager, we can simply go contract, hang on. Contract manager.rpc, which will in turn be this extremely long URL endpoint right here. Cool, first part done. The second part's gonna be the transaction. Now you don't have to call this transaction, you can call it whatever you like. I like to call it transaction, easier to use. And we'll just go, because we use a provider, actually we'll be awaiting, sorry. will be awaiting provider.get, and there's a few things here. Now I know this is really small, I'm sorry, but I can't zoom it in that much. But you can give a transaction, you can give a block with a transaction, you can give a balance, the block number, the fee data, the gas price, the nonce. There's like a ton of stuff you can do using this provider on its own. But we're interested in the transaction receipt. There we go. Now we have to pass it a transaction receipt, right? In this case, that receipt or transaction hash is going to be the transfer transaction, because when we do a call here, this variable here will then return a transaction hash similar to something like that on like an Explorer, something similar to, like, you know, one of these transaction hashes down here. So if I just go to Unity, cool, so that's done. Now the very next step here is going to actually have a conditional statement. So now that we are able to grab the transaction hash, check it on the Explorer and see whether or not it is, you know, 1 or 0, something has to happen with it. So if we go, you can go if transaction.status. Again, there's a few things you can look at within the transaction, but we want the status of the transaction. And we'll make it to string, because at the moment it's just a normal variable. And we'll say if it's 1, then we can invoke this method here. So we can go prove. Hell, we might even throw in a debug just so that we know what's happening. Attempting to approve. No, actually that's a bit bad. Invoking approval method. At least this way we know, okay, cool, it's been a success, or the transaction has been a success. Actually, you know what, we'll do this. We'll keep it simple, we'll keep it straightforward, and we can go, if for instance, you know, the user doesn't have enough tokens, apart from MetaMask already giving you an absurd gas price, if somehow they get through that or they pay that, if the tokens don't get delivered and the transaction fails because of insufficient funds or whatever else doesn't, you know, if any requires aren't met within your Solidity contract, it's gonna trigger transaction has failed. Otherwise, it's gonna be 1, and it's gonna tell us that the transaction has been successful. So what we can do is we can do one more debug. We'll actually debug.log. Debug.log the transaction.status, but we'll also just go cool. So at least now we can actually debug to see what the code is, and then, you know, kind of use that to verify the outcome of this as well. So we're saying that once we try to send the transaction to send the money, if that money has been sent successfully here, we're going to invoke the approval method. Otherwise, if it's not, we say the transaction has failed and we stop it right there. That way people can't cheat your system or cheat the system or whatever you want to say. But we are still missing something up here. We're only invoking the method, but we're not actually doing anything here. So we can then go and we can go, what is it called? We'll go invoke check transaction, and we'll give it about, I don't know, 4 seconds, give or take. You kind of want to give it a little bit of time just to fetch the transaction hash and pass it. If you don't allow enough time, it's going to fail, because it's going to say that this here is undefined, as in the string is null, because it hasn't been able to, well, it hasn't had enough time to get the hash and pass it onwards. You could probably do it for less, but I'll just play it safe and say 4. So now we're going to be sending the funds when we click on this button here. If the funds are sent successfully via this transaction check here, we're going to go straight to the approve, and the user will be given the mint roll. Matter of fact, we can do providing user with mint roll. I mean, this could be anything. You don't have to necessarily use this approval thing. You could have like send money, mint a token. You know, that's another example. And at the end of the day, a transaction check although tedious, it's super great for like, you know, being 100% sure that you know, people won't be able to cheat your game, especially in games, you know, where you've got in-game items and power-ups. You don't want someone to like mint a token or whatever without actually paying you and then abuse your system. Like, that's a really good way of practically having all your liquidity drained over time. So we want to make sure that we have enough security and that we're covered, you know, even at an on-chain level. So let's go ahead. I'll go ahead and build this, and I'll see you guys in a bit, and we'll see what the outcome is. All right, here we go. So we've just built out our little project, and we'll go ahead, we'll connect our wallet. We'll choose our account, that's fine. And yeah, it just shows a connected account. We'll do transaction test, which should then send the funds first, which is very small up here, very sorry guys. So 50 capsule, that's what we're sending. It's gonna confirm, it's gonna wait those 4 seconds. It's gonna debug down here saying that it's gonna check the transaction, and it should tell us what the transaction result is. Give it a moment. Transaction status 1, transaction has been successful, providing user with mint roll, in which case it invokes that next approval method. We go ahead to accept that, and user's been approved for minting. Let's go over to the actual contract itself on the Explorer, and if we just quickly refresh here, 30 seconds ago, there we go, we just transferred 50 capsule. If we go to the actual NFT contract itself, I'm hoping that if we just, whoa, that's huge, refresh here, 20 seconds ago, there's our successful approval as well. So it's so simple that you just add a conditional transaction function that you can use to check the transaction from the previous call. And I mean, you don't even need half of this. You can actually get rid of like all these debugs, you know. You don't have to pollute your space. Hang on. You don't have to pollute your space like I did here. You know, you don't necessarily have to make it so extensive. You can make it quite short and simple, but debugging for me is it's a great tool just to know what's happening, when it's happening, and it's great for troubleshooting and stuff as well. Well, I hope this has been helpful. Thank you for the support. I really appreciate it. If you like this, please like and subscribe. If you've got any questions or queries, either just comment down below or join me in the ChainSafe Discord by just following the link in the description. Have a great day, guys. Bye bye.